I am starting up the stream. Looks like it's running. Hi everyone, I'm TigerHawk3, and today we are going to write a snake game. So here we go. We're going to use tk-enter, stk, class snake is going to be something. We know how that works already. Oh, there's someone in chat already. Fabifighter says hello. Hello. Snake equals snake. I forgot something. We need, I haven't done that in a while. We need, root equals tk.tk. Snake set root dot main loop, and that's how that works. And then we write the rest of the stuff. Now all we have to do is write it. Easy. Okay. We will need new game, etc. So we're going to have some stuff in init and other stuff in a drawboard. Parth Sharma in chat says, hey, how's it going? And in init, we will say, how about we use a canvas in general. Self dot width equals self.width equals, how about, how big should it be? 800 by 800, maybe? And then we could have, squares of size, 50 or something? Doesn't really matter. 800 self dot height equals 800 self dot what should I call it? The dimension of a cell. Cell equals let's start with 50. Fabifighter asks where I'm from. I'm from California. Parth Sharma asks why tk-enter instead of PIgame, because the only thing I've ever used PIgame for before is audio, and PIgame is not included with the standard Python installation, while tk-enter is. So most likely someone who just tries out an arbitrary Python program will be able to run something that only uses tk-enter, but if it uses PIgame, they will have to download and install a third-party library. I think it's okay to use it for audio, mostly because the built-in audio capabilities for Python are absolute garbage, and PIgame is okay for audio-ish. You kind of have to use OGG. Doesn't work that well for anything else, but OGG is a perfectly suitable format. So you can just say, you know, try to import PIgame and then accept. If it doesn't work, they won't have audio. Not a huge loss. Cells 50. Let's see. We're going to have a canvas in the root. Width equals self dot width. Height equals self dot height. What else? I don't think we need the background color right now. What I think we're done. No, we're not done. I'm hoping to do this in one segment, but I tentatively titled this live stream with part 1, just in case, because most likely I'll want to finish something later. Fabifighter says, I'm learning Python, thanks for your videos. Yay, Python is fun. We've got our canvas. What else do we need in the init versus drawboard? What I might do is start with everything in the init and then figure out later what I want to reset for a new game. We define those. We have a canvas. We'll need our snake, which will be... Oh, I know. We need to import something else. Import collections.deck as Q. Notice notice we're using the standard library collections.deck rather than the deck that we wrote like finished a month ago ish. I haven't streamed for a while, but we're using this one instead of that because this is included with every Python installation, and the performance is a lot faster. And honestly, we could get by with a regular list because there's not going to be that many items to worry about for fast, inserts at the beginning. But a deck is more appropriate for this because we're going to have when I hope everyone knows how Snake works. You start with a square playing field, and then you have your dot, and then another dot appears, and you can control your dot, which like moves around. You can turn and whatnot, and then you have to collect the other dots and like eat them like they're food for your snake. And every time you collect a dot, your snake grows in length by 1 dot. And so, yeah, that's pretty much it. Parsharma asks, are you going to provide a source code for this? Yes, I will put it on GitHub as usual, and then I will add it to the description. We'll have a deck. We have our snake. Is going to be... should I have another class for the snake? Or for snake cells? I don't know. For dots? That's a good question. Let's start with, it is a deck. Okay. What is a segment? Let's actually do that. Segment. Do we need to pass it anything to start with? I don't know. I don't know yet. But it's gonna have I suppose we should. It'll have an X location and a Y location. Anything else? Maybe? Fabifighter asks me to explain what a deck is. A deck is the term for a double-ended queue. A queue being a data structure where you add items to one end and remove from the other end. So a queue, meaning like the everyday usage of the term, a queue up for a movie at the ticket office or whatever. It's like forming a line. the term queue is more commonly used in some regions versus others. Like I think it's a little more common in Britain compared to the United States. People here usually say you get in line for something, while elsewhere it might be queue up, but both are the same thing. You have a line, here's the ticket office, and then you add someone from this end, and they go as far as they can, and someone else goes in line, goes in line, goes in line, and this is an NQ, ENQUEUE, so we NQ someone, so then they're in the queue, and when we remove someone from the queue, we DQ them, we take them from this end, because they get their ticket, and then they leave, and then everyone else kind of moves down, whatever. A double-ended queue allows either of these operations from either end. So you can add to this end and take out from that one, or you can add to this end, take out from that one. X, Y. I don't know if this is super useful. Could just be a list. Let's do, oh, I'll need one more thing. It's kind of, yeah. Let's take this out, finish the word import, and say, self dot height 2. Okay, so we're just gonna have a 2-element list. Should that be a list or maybe just a tuple? Will this be changing? Yeah. Okay. Okay. We have our x, y. Oh, we need to take this into account. Divide by self dot cell divided by 2. Okay. So self dot width, this is the width in pixels, by the way. And this is the width in pixels also. Okay, so we have our snake, which starts over there. Let's keep track of which cells are empty. Actually, should we keep track of which cells are empty and which ones aren't? Maybe a set. And sets can't contain mutable items because they are generally not hashable. Wouldn't make sense. Generally, when we have a set or a dictionary, something that's a hashable collection, we are looking for items in it by equality rather than identity, or you would basically never be able to find something again. Let's see, we have our deck with this tuple in it. Don't we want to... No, maybe they should have it should be, no, it's going to be a canvas object. Segment. Self, square, the x position, the y position. Okay, and now we need segment, and we will be, by the way, I do not restrict myself to line lengths of exactly 80, but I also try to keep it sort of reasonable-ish. Like, if it's out to here, it's probably a problem. Self dot canvas dot create rectangle. Is it just XY, XY? I think it is. X1, Y1. I think it's just X1, Y1, X2, Y2. No, I want this thing over here. So X1, Y1. And X2. Oh, no, this is, actually, why do we need to divide by self.self? I don't think we need to. We can just have it be kind of sparse. That's fine. And this should be width over 2, height over 2, plus self dot cell, plus self dot cell. It's actually not plus, this is minus. It could be either, I guess, but then it would be, doesn't actually matter. Let's just keep it plus. We have a tk enter canvas. 0, 0 is at the top left corner. Increasing x goes this way, and increasing y goes that way. We have a rectangle. Rectangle, and we note the width and height. That's going to be the location, basically. Okay. And then, oh, there should probably be a fill. Is the fill automatic? I don't think so. Color equals black. I don't know. Is it color or fill? I don't remember. I don't remember. Fill. Okay. Excuse me. Alright, we have our fill is black, segment, etc. And that's the location. Great. And then what? Then we need to, this is something that we will be changing in drawboard. That's okay. Let's do this for now, and then later we'll figure out what to move into drawboard. Init is going to be something that we only do once when we start the program, but drawboard will be whenever we do a new game. We'll have that. Like, for example, self.parent.bind control n is going to be self.drawboard. And that's going to be our control n for a new game. Simple. Let's put a no op for now. And we have our drawboard. Okay. Let's see. Segment is the canvas rectangle, and the width and the x and the y. Okay. And so when we want to move this this rectangle on the canvas, we will say canvas dot config, or no, it's some other thing. What is it called? Move or transform or something. It's not config. Coords. There we go. So it's going to be coords to change the Fabifighter says, I will watch your tutorial tomorrow due to I should go to bed. Okay. Sounds good, because it will be archived on this channel. So you can totally do that. Working as intended. So to change the, to move a square, we're going to do self.canvas.coords, and then we will pass it this this thing, a segment's square, and then we will say this will move to new coordinates, and then we should update the thing also, the position. Actually, here's an idea. Here's an idea. We're going to use a property. So whenever we change the xy coordinate, it will move the square on its own. And that is going to be property. We're going to have a chord of the self, and this is the getter. Return should we just start with x and y, because we won't have it until we move it. We won't be able to move it until it exists, I mean. We have our square, we have our coordinate. We're going to set our coordinate with something. Should we pass in a list? No. Is this a good idea? I hope it is, because that'd be cool. Let's do the following. Self.x, self.y equals coord. So we will split it into there. Okay, and then every time we set self.coord, it will update and change these variables. Okay. Self.y, good. And then at coord.setter. One day I'm going to make a class that for some reason requires a property called, say, Irish, and then I will have Irish setter. They're good dogs. Anyway, coord.setter. Self C, whatever, the coord. We can actually just call it that. And this will be it will set x and y and then it will move the square. We're going to need that. Equals. We're going to send it to canvas. We're going to send it a rectangle on the canvas. And a rectangle on the canvas is actually just an integer. It's a number representing an object in the canvas. Canvas, we have the square, we have the coordinates, okay. And every time we change the coordinate, every time we set it, we're going to, every time we try to get it, we're going to get x and y. And when we set it, we're going to put that into x and y, and we will move the rectangle. Dot coord or coords. And we need the item, and we need the coordinate pairs. All right. Dot coords, and the item is self.square. And the new coordinates will be, and this is, okay, star coordinates. So I just send them all. Doesn't have to be inside a data structure. Self dot x, because this is the new x. self dot y, self dot x plus cell size. Okay, we can do that too. Cell, we send it the canvas, the size of the cell, and a pointer to the object we're creating on the canvas, and the coordinates that we're using. Cell self dot y plus self dot cell. Okay. I think you can see that this is 96 columns. 80 would be here-ish. 79 would be here. So this isn't really bothering anything, so I think it's fine. Of course, in the old days, many decades ago, this would not be fine because the physical display would not accommodate it. Couldn't do that. In chat, Behi667 says, Hey brah, what's up? For those of you just joining us, we are writing a snake game in tkinter with Python. Change the coordinates. Do we need to do anything else? Oh, we do. We will move this cell to the front of the deck, the head, instead of the tail. And we're going to have the left be... a deck has a left and right, and this is for your viewer right and left. Generally the append and pop happen from the right. So when you append, like appending to a list, it's on the right, because we read from left to right. Usually in the language Python is written in, which is English. So we're going to append to the right, and we append to that way, which is going to be the head of the snake and which will be the tail. It's kind of arbitrary. It doesn't actually make a difference. We just have to remember which is which and which makes the most sense, so that we can remember it and use it consistently. Snake dot append. And do you know why I'm doing this? I'm doing this right here because okay, when we add one, it's going to be append, and because we're adding to the head instead of the tail, we're going to add with append, and when we take one out, do we ever take one out? It's just going to be append. Will we need to... Yeah, when the snake moves, we're removing from the tail and putting it at the head. But when we add a segment to the snake, we're going to be just adding to the head. So adding to the head is going to be append. To head is append. Remove from tail is pop left. Okay. Just going to write that down. Snake. And I'm not sure if this is going to have a lot of information about the snake in this segment. I think I might be okay with that. Honestly, this should probably be a move operation, this thing. Yeah. Yeah. We're gonna take out most of this stuff, because that's kind of, yeah. Okay. Change of plans. Change of plans. Okay. So instead of just sending a new coordinate and having it move, we're going to have something different. We're not going to have this. We're not going to do that. We're just going to have the square and the coordinate. And this is probably okay. We don't actually need to do this. Let's go back to that, and then we don't need any of this. We need some of it, but we're going to move it and do it elsewhere. It's going to be a snake method. Def eat. Def move. Okay. Yeah, I'm pretty sure this is going to need multiple videos. Okay. We don't need the canvas and the cell anymore. We're just going to create the rectangle. And we're going to have the width and the height. And that's going to be our first deck item. Actually, we would need this. You have to pass it uniterable. Segment, etc. Drawboard has nothing. Eat is going to be something. Eat is going to be, how does a snake eat? We add something to the head. And we're going to say it eats something at xy. Great. And move is also going to be to x and y. These might actually be similar, and the only difference is where we get the thing. In eat, we add to the head from a spot on the board, and in move, we add to the head from part of the snake. Yeah. Eat is basically going to be move, because they're kind of the same thing. And we will pass it a segment to eat, because we're going to have segments representing spots on the board. Great. So we have our snake. Let's leave that in it for now. We have our snake. Draw board, eat. Let's see. We're going to have a tick of some kind for time passing. It's going to be something, and then self.parent.after self.tick rate. Okay. There's going to be a bunch more things that have to happen over here. Eat, tick. Let's see. So we have our snake with something. We want to put a another segment somewhere on the board. The rand range, I think, would be good. Food, because the snake is gonna eat it, right? In theory. Self.food equals a segment at canvas.create rectangle at random. We need something. X equals random.rand range width. Actually, should we do this? I think we can just keep track of all of them with like a set or something. Empty. And this is going to be the empty cells. This is going to be a set of just simple coordinates. Maybe it would be easier to just draw the rectangles first and then just change their colors and keep track of which ones are part of the snake. I don't know yet. Could be. Let's go ahead and do that. Squares equals a set of create rectangle x y x plus self dot cell y plus self dot cell for x in range self dot width for y in range self dot height. Okay. Let's say fill equals nothing. I think that's already assumed. That's the default. Okay, now we don't have to create any more rectangles. Let's say these are empty. And our snake will be a deck of ones that are not empty. Okay. Maybe it should be segments? No. It's just going to be squares on the canvas that are available. And we're going to have a segment of should I change things again? We have all our rectangles. Behi says he's from Europe and needs to go to sleep, but we'll catch up tomorrow at work. Keep up the good work and catch you later. Sounds good. I actually don't know what I'm doing here, but that's okay. Let's have it be a tuple, maybe, of locations and segments. X, Y, and the canvas object. Okay. I actually have to 0 self dot width cell 0 self dot height self dot cell. Okay. All right. Are these basically segments? I'm not sure. So we have a deck, and in the deck we will have should this be a dictionary actually? Yes. Yes, it should. X, Y, and that. Okay. That's cool. This is now a dictionary. So we have our XY coordinate and the corresponding tkinter visible square corresponding to it. We have all those. And I don't think we need a segment at all, actually. But which empty one do we want? It is going to be self.empty at self.width over 2, self.height over 2. So we have a deck, and in this deck, something's wrong. This doesn't have a match. Okay. Something like this. I don't know. I'll have to count. So we have a deck, and in the deck we have the self.empty dictionary. Let's actually call it the squares. Let's call it squares for now. Oh, maybe we could just have the fill in this also. I don't know yet. Squares, and we're going to index it with this. And that's the square we want. And that's the self.squares we want. And we need this and then that. Okay. So that's our snake for now, is the deck with this square. And we want this to change color now. This one, move this around, move that around. We have chosen that segment, and is it config? If I want to change the widget options. Where is that thingy? How do I change that? Item config or something? Okay, item config. Right. I knew that. Canvas.itemconfig segment. Fill equals blank. Okay. So we've got our canvas. We've got all the squares on the canvas. Let's do the following. Self.empty is going to be a set of these squares so far. So this is all the squares. This is the set of empty ones, empty coordinates, I should say. And snake is a deck of non-empty coordinates. No, I just want this. Do I want that? I think. Segment this, and is a deck. No, I don't want that. Deck of the segment, but Now I need to do self.squares, because I want the square for this segment, this coordinate. Let's call it a chord. Okay. So now we have our canvas, we have all the squares, we know which ones are empty, and we've chosen the middle one to be our initial snake. And we have colored that one black. And we have our food that we're creating now. Okay. Okay. Random dot choice. You actually cannot use random dot choice with a dictionary or set. It doesn't work because the way it actually works is by basically picking an index between 0 and the maximum length. So, choice of a tuple of self.empty. So we take the set of empty squares, turn it into a tuple. Should that just be a list? Or are we going to be checking if something is in that? No. This should just be a list. So we pick one from self.empty. I want to pop that one out. Would it be easier to make it a list and then pop from the middle, or a set and then pick one randomly, remove from the set? I don't know if there's a tidy way to do that. I will also be changing which ones are empty all the time. How about we keep that as a set, and then this should be a create food. Okay. We pick a okay. We take the set of empty coordinates and change it into a tuple, so we can pick a random coordinate. And then after we do that, we need to say this is the coordinate for food, and then we say we will remove it from the food set, or remove it from the set of empty squares, and color it red or something. Self.empty.remove self.food. So that removes that from the set of empty ones. And self.squares. I don't think this needs to be self, does it? Yeah, things will have to check if it's bumped into it. So yes, self.food. This is actually a item config self self.squares, self.food, fill equals red. Okay. When we create food, we pick a coordinate, and then we remove it from the empty ones, and then we say this one is red, and that is our food. Okay, cool. Let's actually move all this over. How do I, is there a delete the canvas? Delete all, okay. That's all, okay. Job is going to be this. Dot canvas dot delete tk dot all. So when we draw a board, we're going to delete everything from the canvas and redraw everything. There's all the squares. Here's how we know which ones are empty. Here is the coordinate for the middle one that we want to do. And we create our snake. And that's a deck of this coordinate. And then we say the square at this coordinate should be black, because it's part of the snake. And we create food. Let's put drawboard first. I like to do that. Create food, self.food, blah, blah. Okay. Eat. What will eat do? Actually, tick should probably do something. It's going to basically try to move the snake. We have to figure out directions also, because you're supposed to be able to turn the snake. If you couldn't, there wouldn't be a game. So, what happens? We'll need a direction. What are the arrow keys called? In bindings. Events and bindings. I think they're just like up, down. I just want like regular arrow keys. Left, up, right, down. Great. So that's gonna be what I use. Start with, I don't know, right. Okay. And then we'll bind okay. We need one more. Left, right, up, and down. Will we actually, this should be one thing, one function. And this will change the direction. Good. And there's like keysim or something. What's I did that for Tetris. Let's check that out. I think it was keysim. It's the event.keysim. Okay. All right. And we need direction to change the direction. Change direction. Yeah. Then the direction is right. Dot direction equals event.keysim event.keysim. Fine. Left, right, up, down. That should work. Where else do I have this? Direction equals event.keysim. Yeah, that should work. Cool. That's going to be the same left, right, up, down. Very good. All right. What else? What else? Now we have our direction, eat, tick. We can create food. We can change the direction. And okay. So every time we tick, we're going to see if we can move forward in a given direction and what there is there. Maybe eat shouldn't be eat, and we should just do everything in tick. Actually, that's I want to be able to move and reset the tick rate. Okay, so this is going to have to do more than that. I want it to actually move also, if possible. Move in that direction. Parent dot after cancel. Okay, that should reset it. Should this just be key things, it'll just be key press. Because it does more than just change the direction. If we have our snake moving upward and it is here, when I press this way, it should immediately try to go that way. And when I press up, it should immediately try to move this way. Try to move in this direction. Move. Direction. Okay. This should just right. Okay, and it's move that's gonna do stuff, I think. This is pretty good. This is a good start. I like that. Let's move this to here. This to there. We have our canvas, our bindings. This is going to have to probably move into here because we're going to have, when you lose, it'll stop and do something, and then you have a new game. Okay. Pretty good for now. We draw the board. We tick. Let's say... after right tick. So this will give someone 1 second with which to do something, think about the board. So it'll say our ticking is after the rate has elapsed, we're going to call self.tick, and that event is going to be saved in self.ticking, and then after that time has elapsed, it's going to move and schedule the same call to itself and save it again in self.ticking. And if we do a key press, then we're going to... This is only used once, isn't it? Oh no, we do have to save it because it might go in that direction elsewhere. Okay. So we save this as our new direction, and we say we move in this direction, and let's actually cancel this first. We're going to cancel that call. Instead of just waiting for the scheduled one, we're going to say we cancel that, and we'll move manually, and then we will save self.ticking to be the next scheduled call again. Very good. So this is going to be exactly the same. Okay. Is going to move and start ticking again. Okay. I guess I could move this into tick. What would happen if I did that? Just a key press, start tick again. It would cancel the old after call. I could do that. I think this is more clear that it's the key press that's canceling it instead of just calling it right now. Why do these have to be two things? I don't know. None. If not event, no, let's say if there's an event, we want to do these things. Change the direction and cancel that what's it. If there's an event, then we want to handle this manually, and we will say the direction is now this whatever key was pressed, and we will cancel that. And then we will immediately move and schedule the call. But if there was no event, then we will simply move and say take again. No event, move, take again. Okay, that's good. And move will handle the collision detection and eating stuff. Okay. Looks good, looks good. I'm trying to keep this tidy as we go. Move is going to have a bunch of stuff in it, I can tell you right now. Yay. So it's going to have to check the direction. It's going to check the direction, and then it's going to have to look at a certain area on the board to determine whether it can move there, and then do certain things based on that. So let's start with that. That's for down. Okay, if it's left, then we have to check whether there's an available spot to the left. And that's x-coordinate decreasing. And we have to have the head of the snake, which is going to be the 0th element, and we're appending over here, and so that's going to be the first one. Okay, I think. The thing about a deck is it's a double-ended cue, which means both sides are the end. It doesn't have a proper direction. Lists have a proper direction. Appending to the right is fast. Appending to the left is an insert and is not fast, because everything has to move down. but in a deck you're just kind of connecting new elements. Let's see. If the direction is left, let's say the target is going to be the head of the snake, etc. Okay, and the head of the snake is going to be, I don't know if it's 0 or -1. Let's say it's 0. The last one is the head. Whatever. Let's say where do we have our snake? The head is 0 and the tail is -1. Okay. That's our little note that we will have. I think we might, should we do this, do the rest another time, maybe? Because it's been almost an hour and a half. Probably good. Let's get this if else structure done, and that'll be it for the stream. Target is 0. If we're moving left, we want to decrease the x-coordinate. 0 minus self dot cell. One. Okay. Head 0. No. Yes. Head, and this is the x. X and y. Target equals, for moving right, we want x plus self.cell. And y. If we want to move up, we want to decrease the y. Minus self.cell. Target equals xy plus self.cell. Alright. And then there's so this just sets up where we want to move to, and then we will have to check whether it's in the empty squares, or if it's the food. Okay, so if it's the food, we will do one thing. If it's in the empty squares, we will do another thing. If it's food, we will eat it and just add to that end. If it's in the empty squares, we will simply move there. Otherwise, the game is over. So that's something we will do next time. Notice that I haven't even saved this. Haven't done any testing, anything, because I don't expect it to be usable right now. Like I'm still writing it. Snake. I think it will have its own little folder. It will be its own repo. Yeah. Snake. Very good. So this will be Snake in a new Snake repo in my GitHub stuff. And we will complete that another time. I will add the link to the description, and yeah. So I will see you next time. Thanks for joining me. Remember to like, comment, subscribe, blah, blah, blah. And hopefully soon-ish, this week, something would be great if I have an opportunity to do that. So I will see you next time, and thanks for watching. Have a good one.